I welcome you to this lecture, number 4, which is all about regional climatic classification. Okay, it's about to show the distribution of different climates on Earth based on environmental variables. Yeah, we're talking about temperature and precipitation, for the climates on land. Okay, and the naming of different zones. Okay, and this lecture has 3 parts, A, B, and C. And the first part, we start as basic as possible. We just look at the spherical coordinate system that we use on Earth, the geographical coordinates, and then we can define different climatic zones based on latitude. Okay, and that follows the idea that, well, we know that the average solar radiation that the Earth receives depends strongly on latitude. Okay, and then we can define low, mid, and high latitudes. Indeed, we can define the northern hemisphere and the southern hemisphere as well, and we can do a very coarse definition of tropic, subtropics, temperate, subpolar, and polar climates. We can go a little bit more into the details if we look at climates on land, which also strongly depends on the rainfall distribution. You have some very dry areas and you have some very wet areas. And if you account for the rainfall distribution, okay, you can define more details. Okay, and here in part B, I introduce you to the Köppen-Geiger classification system. Okay? Noting that terrestrial life is limited by low temperature and the lack of rainfall, and you already learned about different vegetation zones on Earth, and the vegetation zones that we have are strongly aligned with this Köppen-Geiger classification system. Okay, in part C, I will also want to discuss climatic zones of the ocean. But the ocean is completely different in terms of oceanic life is actually more limited by light and by nutrient availability. Okay, life forms in the ocean are different to life forms or different vegetation zones or biomes on land. Okay, but it's important to talk about the oceans as well, and that's why I want to use the opportunity here to introduce you to surface temperature and salinity distribution, to warm and cold boundary currents, and we're also talking about the plankton productivity in the ocean. So let's get just started, with part A, talking about climatic zones based on latitude. So the first thing that we're going to do is we look at geographical coordinates. Okay, we look at the Earth, and geographical coordinates are based on the axis of the Earth. Okay, just have a look here on the left sketch. Let's get the mouse starting here on the left sketch. Connecting the North Pole with the South Pole. This is the Earth axis, and the Earth rotates around this axis. Okay, so if you now cut the Earth in half, perpendicular to the axis, you actually separate the northern hemisphere from the southern hemisphere. Okay. And you define the equator. Okay. So now, based on that basic definition, of the equator and of the Earth axis, you now can draw circles which are parallel to the equator. Okay, and you can separate it into degrees. You can go 90 degrees to the north to reach the North Pole, or 90 degrees to the south to reach the South Pole, and these circles are called geographical latitudes. Okay? And what's shown here is we cut the upper hemisphere into 3 parts, and we get 30 degrees, 60 degrees, and 90 degrees north. And you can do a similar thing going to the south. Okay? So if you now think about it, and think about the distance between 1 degree latitude circles, and the distance always stays the same, and it's about 111 kilometers. Okay? No matter where you are, the distance between 1 degree circles is 111 kilometers. So now we can define also geographical longitudes, and geographical longitudes are the lines, the sections that you get if you cut through the North Pole and the South Pole. So you have planes cutting through the North and South Poles perpendicular to the geographical latitudes. Okay? And then the definition is you define somewhere where it's your 0 degrees, but then you can go 180 degrees to the west. Okay? And you can go 180 degrees to the east. And on the opposite side of the Earth, you get that line where it's 180 degrees west and 180 degrees east. Okay, there is some discontinuity on the other side of Earth. So what's important here in terms of geographical latitude is that the distance between 1 degree circles, okay, the distance between latitudes of 1 degree is 111 kilometers at the equator, but the distance decreases as you go to the north or to the south pole. Okay, you can see that the distance becomes smaller. Again, that plays a role that's important to know if you want to interpret maps which show longitudes and latitudes. Okay, altogether you can now specify any location on Earth using geographical longitudes and latitudes. Okay, and just for completeness, I want to note that altitude is defined as the height above the average sea level, so moving upwards into the atmosphere. And what we use the word depth is also a positive quantity, but if you go downward into the ocean. Okay, so that's 2 different terms that we use to define the distance from the surface of the Earth. Also for completeness, I want to mention that 1 degree is actually split up into 60 arc minutes, okay? And 1 arc minute is split up into 60 arc seconds, but nowadays we also use decimal notation. So you have to be careful when looking at maps or when looking at coordinates, whether it's actually in this arc minutes and arc seconds or whether it's in decimal notation. All right, here we go. So now we do the first thing we do, we define the terms low latitudes, mid latitudes, and high latitudes. And the way this is done is that the Earth is cut into sections based on 30-degree differences in geographical latitude. Okay, so you can see that here in this graph. We have low latitudes both in the northern and in the southern hemisphere, from the equator to 30 degrees north, equator to 30 degrees south. We have the mid latitudes from 30 to 60 degrees, and we have the high latitudes from 60 to 90 degrees. Okay, and we have the northern hemisphere and we have the southern hemisphere. And these words are often used when we talk about low latitudes, high latitudes, mid latitudes. And from now on, you have to know what is meant by these terms. Okay, we can go a little bit more into details. Yeah, a little bit more into details on the next map. Okay, we can define some subdivisions. And the idea here is this very coarse definition of climatic zones is based on the average incoming solar radiation. Okay? It's highest near the equator and lowest near the poles, and we can split up zones further into detail into the tropics, into tropical and subtropical regions. I mean, I should have mentioned that indeed also the rainfall plays a big role here. You will learn that near the equator we have a zone of a very strong rainfall called the intertropical convergence zone. Okay, and this is actually what more distinguishes the tropical from subtropical regions. Anyway, so you can see that the zone from the equator to 30 degrees we can cut in half and define the tropical and the subtropical regions. And we also the high latitudes we can do the similar thing. We can distinguish subpolar from polar regions in both hemispheres. Okay. Mid-latitudes are often also called temperate zones or temperate climates, the mid-latitude zones. Okay, and sometimes we also have a inclusion of an equatorial zone. The tropical regions are sometimes included in equatorial zone. Okay, equatorial, say from -5 degrees south to 5 degrees north. Okay, and this is the end of the first part of the lecture. Okay, and I urge you to learn these words. So if someone says subpolar or temperate zones or polar zones or subtropical or tropical, you should get an idea of which locations we are talking about.